sample data from a student in one of our classes for the estimated population based off different sample sizes. So what we want to do today is we want to construct a box plot in order to capture this information better, to analyze it. So what do you guys think I should be doing first if I want to construct a box plot for this data?
Find the thingamajiggies, the lower thing in the lower quartile and the higher quartile.
So I heard we need to find the lower quartile. I saw someone said we had to find the median. I heard upper quartile.
The mean.
So I'm going to write the mean over here. Do we need the mean or the range in order to make a box plot? We need the maximum. That's good. And the minimum. So do you guys remember what we call this? Does anyone remember what this is called?
The 25% thing.
This is called our 5-number
Our 5
summary.
number something.
Great. And then if we also want to look at some other things, so I heard someone say average, range, mode, okay, now what should we be doing next? We know what we need to look for. How do we find it all? Okay, so how do we find the minimum, lower quartile, median, upper quartile, maximum? How are we doing that? Not sure, okay.
Wait, the sample size or the estimated population?
The estimated population. That's the data we're looking at. Put the numbers in order. Okay, Nicole's saying to put the numbers in order. So I'll do that over here. We have 185, 205, 275. Sorry about your computer lagging. 283, 315. I think everyone's is lagging. Mine is lagging a little bit too. That's okay. 575. Great. I've put the numbers in order. So what should we be doing next?
The minimum and the maximum.
So minimum and maximum. Okay, the minimum is 185. The maximum is 575. Great. How about next? What should we be doing next? Median. Caitlin, how do we find the median? Count? Caitlin, what do you mean count? The middle number. Okay, Caitlin, can you tell us the middle number? Do you want to turn your mic on and tell us what the middle number is? Or anyone else want to give their input into what this middle number is, the median? 279. I don't even see 279. Does anyone have an idea how she came up with 279 if we don't see it there? Does anyone have an idea? Because there are two middle numbers. Okay. So we're noticing there are two numbers in the middle, which means in order to find the median, what do we need to do?
Divide.
We just divide, that's it, just divide. Average them. Okay, so you guys are telling me that I want to take the two middle numbers, 275 plus 283 divided by 2, and that gives us 279. Okay, now what? Sorry, what should we do next?
The lower and upper quartiles.
Okay, who wants to help me find the lower quartile? $205. So we look from the minimum to the median, and we look for that number in the middle, 205. Now we need to find the upper quartile.
315.
315. Let's see. Start from the median, go to the max, look for the number in the middle, 315. Fantastic. Okay, now what do we need to do?
Make a plot.
Okay, so in order to make a plot, the first thing I'm going to need to do is construct a
Graph.
number line. Okay. And now we have to come up with a scale for our number line. You want to count by fives, Nicole. Okay, what's the smallest value I'm going to need on my number line? 185, okay, so I might go to like 180. And what's the largest number I'm going to need on my number line? 575. Do you guys think it's a good idea to count by fives then?
No.
No.
Anyone have an idea of something we should count by or what our scale should be?
Tens.
Tens?
20.
20, 25 I'm seeing.
50.
50. Let's go somewhere in the middle. Maybe 20 will be okay. What do you guys
60.
think about, what do you guys think about counting by 20s?
80.
8 is a weird number to count by because it'd be hard to keep track. I think
100.
I'm hearing 20, 20, and 25.
123.
120.
Okay, 20. I'm hearing mostly 20, so I'm gonna start counting by 20.
Counting.
120s.
Stop the cap.
Blueberry Fango.
Okay. Notice I don't have to put numbers everywhere on each tick mark, but I know each tick mark counts as a scale of 20.
Stop the cap.
All right, who has an idea what I should do next? Guys, let's try not to interrupt unless we're answering questions or focused on the lesson. Mark the median. Okay, so let's mark the median. The median was 279. Okay, 279. Then mark the lower quartile and the upper quartile. Okay, I'll do that in the matching color. So the lower quartile was 205. And the upper quartile was 315. Okay. Jaden's saying we need the maximum and minimum. So the maximum is 575. and the minimum is 185. Now what? Does that look like a box plot?
No. You need to make the boxes.
So where does the box go? Oh, make the box with the upper and lower quartile.
The lower quartile, and then go to the upper quartile, and then, yeah.
Does anyone know what the range is? Did anyone calculate the range yet?
We find the range again.
Who wants to answer that question?
You take the highest number in the data set and the lowest number in the data set, and you subtract the lowest numbers from the data set from the highest, and then you get your range,
Okay.
which is 390.
And how do we find the IQR?
You do the exact same thing, just with the highest quartile range and the lower quartile range, and you subtract the lower quartile from the higher quartile range.
Does someone want to do that for me? $315 minus 205. 110. Do we have a mode? Nope. And can someone calculate the average for us? Is anyone able to calculate the average of this data set? $311.8. Do we agree with that? Can we get a confirmation that that's what someone else got as well? Okay, we have two different answers now, so let's try to... Ryan, do you want to recheck it? We're getting 306 and a third. Six and a third. Okay. So we have a lot of information here, and now we want to do a little bit of analysis. Does anyone have an idea, or just want to share? Maybe turn on your mic and share some thoughts about what you're seeing here. What's probably the most interesting thing that we're seeing in terms of the box plot? Like, what's standing out to you? Again, turning your mic on might be more helpful.
A 575.
So, what's going on with the 575?
It's very spread apart.
Okay. Who wants to add on to this idea?
There's no duplicates of numbers.
No duplicates of numbers. It's very spread apart.
The maximum is way higher than the average.
Ooh, the maximum is way higher than the average. Yeah, look, the average is 306.3 repeating, and the maximum is way higher than the average. Why do we think that's happening? Why do we think the maximum estimated population is way higher than the average?
Probably different sample sizes that people had.
So this is one person's data. This is one person's data. They took 6 different samples using different sample sizes. So in one sample, they only had less than 30 fish. Then in our second sample, they had between 40 and 60 fish. Then they had between 65 and 85 fish in their sample, and their sample size continued to increase. So let's maybe kind of add on to that. What do we think about the sample size and our estimation? Any ideas? Again, you can type your response or you can speak your response by turning your mic on. What do you guys think about how sample size is having an effect on our estimation of the population? Ryan, today I'm almost done with the lesson, and then we'll be able to go to do your own work, okay? So I'm just trying to answer a few more questions, and then we can do your own work. So my last question is, before anyone leaves, what is the relationship between sample size and our ability to estimate the population? We're noticing this 575. There's something happening here that you guys are noticing. It's really spread out. It's far away from the mean. It's far away from the median. It's not near the cluster of data. It's kind of away from everything, and I'm wondering why that happened.
Maybe because of their data, like how many tagged fish they got.
So Nicole just said the more data we get, the more accurate our estimation is. What do we think about that?
That's true.
You guys think that's true? So what's the opposite statement of that?
The less data, the less accurate it is.
The smaller our sample, and the less data we have, so maybe you could just read that to yourself for a second. The smaller our sample and the less data we have, the less accurate our estimation is. It's a pretty interesting idea because if you look up here at our sample sizes, right, our larger samples have data that's more clustered together. Meanwhile, our smallest samples data is not clustered with the rest. And I'm wondering if you're going to see that on your own work when you go back to your original data, if that's going to be the same thing, kind of same idea, or maybe not. I don't know, because you all have different data. So your objective is to go to do this on a piece of paper, this type of analysis on a piece of paper using your own data, construct a box and whisker plot, look at some other measures of variability and of center, and then you're going to be producing, you're going to put this picture on that document that I shared with you, as well as a small write-up. So the more you write, or maybe it's not about how much you write, it's about the, yes, Ryan, the more measures we have, the more we can write up in our response to the best estimation for the number of fish. So I don't want to give like too much away now. I want you to try it on your own and come up with some ideas about how you're going to come up with one final estimation of fish. So if you looked at all this data, you could start to think about what your final estimation of fish might be in that pond.
Well, I don't know what my data is.
I shared the link with you. I'm going to do that again. Are there any other questions? I'm going to end this help session, the recording.